Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first three parts of graphs where I have covered how we can plot the graph of linear functions, quadratic functions and functions with modular sign. In case if you haven't gone through those videos, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In this video, we are going to see how we can plot the graph of higher order polynomials and the graph of some more functions. So let us start with today's video. Before seeing the graph of higher order polynomials, I would suggest you all to go through the inequalities videos first, where I have covered how we can find the range of values of x which would be satisfying a given polynomial, as we'd be requiring the knowledge of inequalities in plotting the graph of higher order polynomials, the link of which I have given above and also in the description box. Now suppose we have been given a fourth order polynomial px as x minus 2 times of x minus 5 times of x plus 6 times of x plus 10, and we need to plot the graph of this polynomial. Well, to plot the graph of higher order polynomials, first we need to find those range of values of x for which this polynomial would be attaining positive values and negative values, which we have already seen in the inequalities video. So first, let us try to find those range of values of x for which this polynomial px would be attaining positive value and negative values. So to find those range of values of x, first we need to draw a line and put the critical points. In this case, the critical points would be plus 2, plus 5, minus 6 and minus 10. So let us try to put these critical points on this line. So minus 10 would be somewhere here, minus 6 would be somewhere here, plus 2 would be somewhere here, and plus 5 would be somewhere here. And between minus 6 and 2, we'd be having the origin. Now, if we take a value which is more than 5, in that case, this polynomial px would attain a positive value. For example, if we take a random value of x to be 10, say, in that case, x minus 2 would be positive, x minus 5 would be positive again, x plus 6 would be positive, and x plus 10 will also be positive. And the product of these four positive numbers will also be positive. So, for values of x which is more than 5, this polynomial px would be attaining a positive value. In a similar way, for values of x between 2 and 5, this polynomial px would be attaining negative value. Between minus 6 to 2, it would be again attaining positive value. Between minus 10 to minus 6, it would be attaining negative value. And for values lesser than minus 10, this polynomial would again attain positive values. So this polynomial attains a positive values for x lesser than minus 10, for x between minus 6 to 2, and for x which is greater than 5. And it attains negative values between minus 10 to minus 6 and between 2 and 5. And at the critical points, that is at x equal to minus 10, at x equal to minus 6, at x equal to 2, and at x equal to 5, this polynomial attains a value of 0. So if we plot the graph for this polynomial, the graph would be something like this, where this line would represent the x-axis and the y-axis would be somewhere like this. From this graph, we can see that as we go to the left side of minus 10, the value of px is positive and it keeps on increasing. In a similar way, if we go on the right side of plus 5, in that case, px attains a positive value and the value keeps on increasing. And between minus 6 to plus 2, the value of px is positive, and initially the value of px kept on increasing and then it attained a local maximum value, post which the value kept on decreasing, and then it attained a value of 0 at the critical point, that is at x equal to 2. In a similar way, between -10 to -6 and between +2 to +5, the polynomial px attains negative values. And when we kept on increasing the value of x from -10 to -6, initially the value of px kept on decreasing, then it attained a local minimum value, and then again it kept on increasing till it becomes 0 at the critical point -6. And in a similar way, when we kept on increasing the value of x from 2 to 5, first the value of px kept on decreasing and it attained a local minimum value, post which the value of px kept on increasing and it attained a value of 0 at the critical point x equal to 5. So this should be the rough sketch for this polynomial px. So to plot the graph of higher order polynomials, first we need to find the critical points. And then we need to put these critical points on the x-axis, post which we need to find those range of values of x for which the polynomial would be attaining positive values and negative values. And then we can plot the rough sketch of any given polynomial. Now, this polynomial px can also be given inside a modulus sign, and we have to draw the graph for it. Well, in such cases, everything will remain the same except these negative values will now become positive, because modulus function always give us positive values. So the graph for this polynomial inside the modulus sign would be this graph. That is, the graph is exactly same, only the negative values in this graph has now become positive. So in this way, we can plot the graph of higher order polynomials inside a modulus sign as well. Now, let us increase the power of these factors and let us see what will be the change in the graph for this polynomial. So here I have increased the power for this factor x minus 2 to 4 and increase the power for this factor x plus 10 to 3. We have seen in the inequalities video, whenever the power is even, in that case, we don't consider the critical points from that factor. So if we draw the number line or the x-axis, and if we plot the critical points on this line, in that case, the points would be -10, -6, and +5. But we are not considering the point +2 on this line as the power here is even. Now we need to check on this range of values of x, that is for x lesser than -10, for x between -10 to -6, for x between -6 to +5, and for x greater than 5, this polynomial px is attaining positive value or negative value. So if we consider any random value which is greater than 5, say x equal to 10, in that case, this would be positive, this is positive, this is positive, and this is positive. So any value which is more than 5, in that case, this polynomial px would be attaining positive value. So between -6 to 5, this would be attaining negative value. Between -10 to -6, this would be again attaining positive value. And for values lesser than -10, this polynomial px would be again attaining negative values. So if we draw the rough sketch, in that case, the graph would be something like this. That is, for values of x lesser than -10 and between -6 to 5, this polynomial px is attaining negative value, and somewhere between -6 to 5, it also attains a local minima. And from -10 to -6 and for x greater than 5, this polynomial px attains positive values, and somewhere between -10 to -6, it also attains a local maxima. But if we look carefully to the expression of this polynomial, in that case, we'll find that this polynomial attains a value of 0 at x equal to 2, 5, -6, and -10. But from the graph, we can see that the polynomial px attains a value of 0 at x equal to -10, -6, and at x equal to 5. So we need to make the value of this polynomial 0 at x equal to 2 as well. And x equal to 2 would be lying between -6 and 5. So let us assume the point 2 to be somewhere here. So at x equal to 2, this polynomial px attains a value of 0. So if we restructure the graph, in that case, the graph would be something like this. That is, at x equal to 2, the polynomial px would be attaining a value of 0. And it attains local minimas at some points between -6 to 2 and between 2 and 5. So for such kind of cases, we need to be a little bit cautious to make sure that we are not missing such kind of points. So this is the rough sketch for this polynomial. Here also, if we put a modulus sign, in that case, all these negative values will become positive. And the graph would be something like this. That is, everything remains the same, only this negative values has now become positive. So in this way, we can plot the graph of higher order polynomials with or without modulus sign. Now, sometimes we might be given some random functions and we need to plot the rough sketch for those functions, which we can do simply by taking some random values of x and by putting the corresponding values of y. For example, say we have been given a function as y equal to 1 by x and y equal to 2 raised to power x, and we have to plot the rough sketch for these functions. First, let us draw x and y coordinate axis and let us take some random values of x. At x equal to 1, say somewhere here, the value of y will also be 1, let's say somewhere here. At x equal to 2, the value of y would be 1 by 2, that is 0.5, say somewhere here. At x equal to 4, the value of y would be 1 upon 4, that is 0.25, let's say somewhere here. And at x equal to 8, the value of y would be 1 by 8, that is 0.125, let's say somewhere here, and so on. So that means if we keep on increasing the value of x, the value of y keep on decreasing. Now, if we keep on decreasing the value of x from 1 till 0, in that case, the value of y will keep on increasing. For example, at x equal to 1 by 2, say somewhere here, the value of y would be 2, let's say here. In a similar way, at x equal to 1 by 4, say somewhere here, the value of y would be 4, let's say somewhere here. In a similar way, if we keep on decreasing the value of x till 0, in that case, y will take very high values. And for values of x close to 0, in that case, the value of y will be tending towards infinity. Now, if we join all these points, we'll be getting this graph. That is, for values of x which is closer to 0, in that case, y is attaining a very high value. And as we keep on increasing the value of x on the right side, the value of y is getting decreased. And for very high values of x, the value of y will be tending towards 0. In a similar way, on the left side of the origin, if we take values of x which is very close to 0, in that case, y would be tending towards minus infinity. And if we keep on decreasing the value of x till minus infinity, in that case, the value of y will be tending towards 0. So for values of x lesser than 0, the graph would be something like this. So this would be the rough sketch for the function y equal to 1 by x. In a similar way, if we plot the graph for y equal to 2 raised to power x, in that case, at x equal to 0, the value of y would be 2 raised to power 0, that is 1, let's say somewhere here. At x equal to 1, the value of y would be 2 raised to power 1, that is 2, let's say somewhere here. At x equal to 2, the value of y would be 2 square, that is 4, let's say somewhere here. At x equal to 3, the value of y would be 2 raised to power 3, that is 8, say somewhere here, and so on. In a similar way, if we go to the left side of the origin, in that case, at x equal to -1, the value of y would be 2 raised to power -1, that is 1 by 2, that is 0.5. And at x equal to -2, the value of y would be 2 raised to power minus 2, that is 1 by 4, which is 0.25, let's say somewhere here, and so on. So if we keep on decreasing the value of x to the left side of the origin, in that case, the value of y would be tending towards 0. And if we keep on increasing the value of x to the right side of the origin, the value of y will keep on increasing. Now, if we join all these points, we'd be getting this graph. So the rough sketch for y equals to 2 raised to power x would be this graph. So in this way, we can plot the graph for such kind of functions. So that's it for today's video, in which we have seen how we can plot the graph of higher order polynomials and the graph of some more functions. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.